Okay, so we'll be discussing now about the types of machine learning that are there. Okay, so there are mainly three types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. So broadly, we have only these two types: supervised and unsupervised, and we also have reinforcement learning. We look at all these types one by one, just theoretically, and the math and in detail we will look at when we start with the individual techniques later on.
Yes.
Okay, so supervised learning is very simple. Supervised learning means there is a supervisor, just like a teacher in the class, and he is telling you things. Okay, this is Africa, this is India, this is Europe, this is a car, this is a chair. So the teacher is showing you examples with labels. This thing is called this thing is called this thing does this. So whenever you are learning from examples where each and every example has a label and you have to understand or learn the label. Okay, that is called machine learning. Okay, so we have
Yes.
a labeled example. So this label term is very frequently used in machine learning, right? So label means what's the name of that thing. Okay, so we have data, we have a target response, again the same thing, like what is that particular row, right? So I feed it to a machine algorithm, I make it learn just like we saw yesterday, right? And once the machine learning learns, now I can use new data to you, I can use machine learning model to give me the correct response, right? So there is a child, for 1 week I told him about all the different animals. This is monkey, this is cat, this is dog, this is buffalo, this is a zebra, right? And on from the next week I am showing it, okay, now tell me what is this, now tell me what is this. So he'll probably perform in some way, right? He will tell some correct answers and some wrong answers. So if the child is telling more wrong answers, that means I need to train him more, teach him more, right? So we will do this training unless my model is becomes some kind of accurate, some 99% accurate or some 90% accuracy based on my requirement. So this is what supervised learning is about, learning from
Right.
labeled examples, right? So now what are the different problems, or what are the different ways in which I can use supervised learning? So one is a classification problem, one is a regression problem. Classification problem is just now what we discussed. This is a cat, this is a dog. So based on a picture, tell me what this thing is, right? So my I have to classify objects into different categories, right? So suppose based on your marks, I have to tell you whether you are first grade or second grade or third division, right? What is your rank? And other kind of problems are regression problems, where I want to predict a continuous variable. What is the price of this product, what is going to be the height of, so suppose you are not you so suppose you will get married in future, I want to predict right now what is going to be the height of your son, right? So height is a continuous number, it can be anything between like 2 feet to 6 feet or more, maybe more than that, right? So it is an individual number. So it can be 3 4 5 3.5 3.7 5.78, or it's a real number. So when my outcome that I want to predict is a real number, I will call it a regression problem. When my outcome is kind of a category, whether there is a ball or the bat or a male or a female, whether it is spam or not spam, it will be a classification problem, right? Because classification, you get it, my output will be falling into different categories, it's a classification problem. When my output is
Yes.
a real number, it's a regression problem. Okay, let's take some of the examples. So supervised learning, this is the basic structure of supervised learning when it is applied to a classification problem. So I have set of inputs, then this is my model, and my output is some categorical response. So I input a picture of cat, it should take say cat. When I input a picture of dog, my model should say dog. So the output is a categorical response, means my output falls in one of the many categories. Okay, and here it can only fall into just one category. So if I show a picture of cat, it cannot be 50% cat 50% dog. Like till now we are not considering that. Next is the mail a spam or not? So based on the mail ID, IP address, subject of the mail, and the timing, these are my inputs, right? These are generally like, this is what we look into. Maybe so what is the subject of the mail, what is the content of the mail. Based on that, I make a prediction whether it is a spam or not. So my output is always falling into these two categories, yes or no, is spam or not spam, right? One more example. Will it rain today? This is my question. So based on the humidity, temperature, and wind speed, these are my parameters. I can have many more, maybe sunlight or what parameters, I don't know. It will depend on this particular domain, right? Weather forecast, weather domain, weather forecasting. So when I give these three inputs to my model should say whether it will rain yes or no. It is not saying how much centimeter of rain will happen or how long will it rain, 4 hour, 3 hour, right? So if the question was about how long will it rain, it becomes a regression problem, right? It is basic classification, whether yes or no, yes or no. So most basic type of classification is 0 1, whether yes, no or yes, only two outcomes, right? So if you study for 7 days and you study from these books, whether you will pass or not, it's a classification problem. If I say if you study from these books for 7 days, how many marks will you get? That's a regression problem. Okay.
Yes.
Next is supervised learning example in regression. So I have a same structure is same. I have a set of inputs. My prediction is going to be a continuous response, a real number. Okay, so let's take an example. Suppose I want to predict the house, the prices of any house in any city. So what will I look at? Some of the features are what is the number of rooms? What is the age? How old is the house? What is the area of the house? I give these inputs. These are like 2 and 7 and 13 and make a prediction. So the price is around this. It is what? 3,50,000 is very cheap, but yeah, it can be in dollars. Okay, so it's basically in dollars. We will look at this particular problem in our machine learning, like in more detail. So we'll be solving this. So it's the outcome is a real number. Next is what is the value of the stock. So based on the GDP, what is the profit of the company, last trading price and industry average, all these parameters, when I put into it, what is the value of the stock, right? So whether the stock will go up or go down. So value of the stock means what is the price of the stock, right? So it will be a continuous number. Okay, so this is the difference between classification and regressions, right? Next comes unsupervised learning. Unsupervised learning is where there is the you have data but there are not there, but labels are not there. Okay, so basically suppose you think of an example of sorting, right? So yeah, waste. So you are putting, when you are putting waste, you just think of, okay, dry waste or wet waste. You are segregating it in different ways, in these two ways. Next, you want to make your wardrobe, clean your wardrobe or sort your wardrobes, right? So all the products, their labels will not be useful. So, right, so all the small clothes will go here, all the shirts and jeans will go here, all the socks and all the handkerchiefs will go here, right? So based on the size, some different so you do not consider then the label, whether it's, so there is no specific shelf for a t-shirt or a collar t-shirt or a shirt. So you just club them together, you kind of sort them and arrange them in a different, in an order based on your own understanding. So unsupervised learning is basically you have data but you do not have the classes, right? So you can say, so if you go to remember your school days, in the lunch time in the football ground, the students are roaming here and there in groups. So you can clearly see there are some groups but you cannot label them. You do not know, okay, are these friends? Yeah, yes, they are friends and they belong to the same class. You do not know what is the property which is holding them together in the group. You just see there are 500 people in the ground but they are in different 10 different groups. So maybe based upon they may belong to the same class, they may belong to the same bus they come from, maybe they are living together after the school, or maybe they are belong to the same team, right? So you do not know these labels, like are these friends or not. Just based on your data you are putting them into groups, right? So you do not have any known example before, right? So I have data, I will apply machine learning and I will get my output as grouped into different clusters, right? So unsupervised learning is without the labels. I'm grouping my data based on some similarity, which I right. So the new data, when the new data comes, our model will tell, okay, put this thing in that group, put this thing in that group. Maybe it will become more clear in this example. Okay, so basically here is my data. I am putting it into a machine learning algorithm and my algorithm is giving me this output, right? So basically this is my input data, right? So it is, you can see circles and squares of red and blue color. So one way of arranging these things as all the squares one side, all the circles one side, this way. Next way is to that all the big things one, so these things are all big in size, these things are small size things, in one way. Other thing is that I can sort based on just the color. Okay, red things this side, blue things this side. So whenever a new input comes, I can say, okay, put it in the blue thing or the red thing. So in use based on just this data without any label example, I did not say, okay, sort them based on the shape, sort them based on the color. I did not say that. I let the machine learning algorithm itself that find out what in what different ways I can cluster them into different groups based on some similarity. Here the similarity is shape. Here the similarity is the size. Here the similarity is the color. Right. So when a new data comes, I will just use this learned or build model to tell me which group this should belong. So now suppose if I enter a red color circle, so it should group them into one of these three types, into one of these three groups. So basically they are not three groups, they are different three strategies which my machine learning model is learning by itself, right, based on this data. So there is no predefined label, right? So next is unsupervised learning. What are the examples? So one example is clustering, which we saw, which we'll see again. Then is anomaly detection. Anomaly detection is that something abrupt is happening, something out of the routine, some odd one out thing is happening in a cluster, right? So every day your friend, so you every day everyone comes to the class wearing the same dress, right, the school dress, but one day the guy came with a different dress, maybe it was his birthday, so he was an anomaly, right? So anomaly is like something which is different than the usual. Then we have association. Association means how can I club different things together in a supermarket? So if you go to buy tea, the sugar should be placed somewhere next to that shelf, tea shelf, and biscuits and all the bakery products should be placed near to the tea and milk and bread section, right? Makes sense. So how can I agree, how can I associate different data points together to make it more meaningful, right? So this example is, suppose this is my input data. So because we are humans and these are objects we have seen before, it's a football, basketball and rugby ball or whatever we call this, I don't know if it's a ball, but yeah. So I am giving it to a machine learning algorithm, and based on its based on its some calculation, it is giving me output as this, like different, is sorting these things out now, right? And when I have given it multiple examples, like maybe 10,000 examples, this strategy it has defined. Maybe it just like a human, the machine learning algorithm has tried to understand, okay, this thing is a ball, or this thing is separate, this thing is separate, and this thing is separate. So we know, like, we by color I can differentiate, by the exact name I can differentiate, because I know it's a football. But the machine learning algorithm does not know, and we are not feeding that label information. So based on its practice and based on the learning that it did for every data point, it made this rule, and which is almost correct also, right? Next comes the reinforcement learning. Okay, so now reinforcement learning is learning by mistakes. Okay, so if you take your bike, you go out, the police catches you, when it is the first time, you get all scared. Now he'll call my dad, I'll go to police station and all, I'll be in jail. But once you realize, okay, you can just stop, maybe after giving a warning he leaves you and you become, okay, fine, now I learned that, okay, the police is not always harsh, I do not land up in jail, they maybe just take a fine and give a warning, right? Second, there is a kid and he's sitting with his parents, and his parents are drinking tea. The kid says, I will drink, I want to drink, and he drinks the hot tea and his tongue gets burnt, right? Now he will, for his entire life, he will remember that from that feedback, that thing was very hot, I felt very pain in my tongue, so I will not drink that thing again, right? So based on some kind of reinforcement, based on some kind of a failure or some kind of a success, some kind of feedback is there, I'm learning from that. So for example, if you are learning maybe a new skill, right? So if I say, okay, if you, I'm giving you a program, you write this program and show me tomorrow. You wrote the program, you showed me tomorrow, and it was really great, I gave you very good, excellent, or I maybe paid you money for doing this good. And the other day, and I gave you one more program tomorrow, and then when you wrote that program, it was really bad, and I gave you, now you give my money back, or I gave you negative feedback, very poor, I talked to your father, okay, he's not doing good. So this kind of feedback, based on this feedback, you are improving your performance, right? So if I'm getting feedback, good feedback every time, that means this is the right thing to do. If you are a cricketer or a footballer, if you are if you're batting very nicely, everyone is clapping, then you realize this is the right thing to do. If you're not batting, you're getting hit on the body, everyone is saying, okay, do this, try this out, duck it, or maybe take a shot, or just get out, right? So learning from feedback after you have performed an action is called reinforcement learning. So the feedback can be positive or negative. Positive feedback means I'm doing the right thing, negative feedback means I'm doing the wrong thing. So same thing when I applies to a machine learning agent or a system. Okay, so I will not tell what to do. I will just give input, and there will be some operations that the system can perform, and every operation will have an outcome, and every outcome will have a reward. Okay, so if my machine I have data, my machine learning algorithm will perform something. This action will have a feedback, and based on the feedback, it is learning whether to do it or not. Okay, so similarly, after I have trained it for multiple scenarios, it will have a policy, or it will have a kind of behavior developed. The machine learning will develop a behavior to, or an approach to solve a problem, right, based on the all the data and all the feedback and all the actions it took. Okay, so if I blindfold you and I leave you in your house, so you will take what? Maybe you can go right, left, forward, backward. Only this much you can do, and you can touch the walls. So if you hit into a wall, you say, okay, I went right, I went forward, and I went into a wall. Let's try a different thing. I go left, then I take right. So I ask you to reach this particular room blindfolded. So whatever information you have is, I can take some actions left, right, forward, and I can take feedback whether it is a wall, whether I am getting hit on the face or not, like that. Okay, and once you reach that particular target, I'll say, okay, here is your chocolate. Right, so basically now you can track back. Okay, after taking left, right, then forward, then maybe left, right, I reached here, maybe this is the right thing to do. So you will remember those the path you took to reach that room blindfolded. Right, similarly, my machine learning algorithm will learn the strategy to correctly classify something, or maybe do a regression problem, or predict something. Right, so this new data comes, and my trained model can be used to make some reinforced response, or which is going to be really good, because the model has been trained multiple times. Right, so this is what machine learning. There are different, these are the three types of machine learning. Right, so that's it for today. Thank you for your time, and we can meet again tomorrow, right, or maybe day after tomorrow.
Anytime, sir.
Okay.